This video is to provide some more examples of adding and subtracting rational expressions. So in the previous video you've seen how to add or subtract rational expressions when you already had a common denominator. We talked about how you would find a common denominator, and you've seen a few examples now using that to add or subtract. Here we're just going to do a few more examples just to make sure that we have all of this down. If I said to add 1 over 8x squared y plus 5 over 12xy to the third. The first thing you should be thinking about here when you see this is that, first off, the operation's addition. So if I wrote perform the indicated operation, that's how you know you're adding, because of the plus sign. And then to add two fractions, you need a common denominator. Now, usually we would say factor the denominators completely, but since these are monomial terms, this is actually easier, but people get confused after seeing the other way of doing it. Since these are monomial terms, there's no factoring involved at all. So if we're looking for an LCD here, right, we need a least common denominator or lowest common denominator to add fractions. For the coefficients, the 8 and the 12, you want the smallest number. 8 and 12 are both factors of, or the smallest number they both go into evenly. And so for 8 and 12, that would be 24. Right? You want the lowest one, so 24 is the lowest one. And then you look at the variables. We have x squared and we have x. Remember how this works. You want the highest power that you see of the variable. So we want x to the second power because it's the least common denominator. So we can make this x look like an x squared, but I couldn't make this x squared look like an x by multiplication. And then we have y and y to the third, so we want y to the third. All right, so you want the highest power of each factor, each variable you see there. So then remember what you're doing. You're rewriting each of these using the LCD. So it's basically figuring out what's missing from the denominator, and you multiply by that to get to the least common denominator. But then if you do it to the denominator, you got to do it to the numerator. So we know that we want to write this as 24 x squared y to the third in the denominator, so you have to ask yourself, what do I multiply 8x squared y by to get to 24x squared y to the third? Well, 8 times 3 would give me the 24, so I'm multiplying by 3. X squared is already x squared, and then y, to get to y to the third, we need y to the second. So we're multiplying by 3y to the second. If you're doing that in the denominator, you also would have to do that in the numerator. So 3y to the second times 1 makes this 3y to the second power. All right, the plus sign stays plus. And then again, we're writing the second fraction here, 12xy to the third, as something in an equivalent form over the LCD, which is 24x squared y to the third. And so you ask yourself the same type of thing. So 12xy to the third, what did I multiply that by to get to 24x squared y to the third? Well, 12 times 2 gives me the 24. X times x gets me the x squared, and then y to the third is already y to the third, so I don't need it. So I multiply the denominator by 2x to get to here. Whatever I do to the denominator, I got to do to the numerator. So 5 times 2x makes this 10x. And then remember, once you have a common denominator, you just want to add or subtract with subtraction straight across the numerator. So here, 3y squared plus 10x, and then it's all over that same common denominator, 24x squared y to the third. And then lastly, you should check to see, can you simplify this? Well, in this case, does this simplify? To simplify, you try to factor probably initially here. To factor from the numerator, there's no GCF other than 1, so there's nothing you really can factor out. It's not the sum or difference of perfect cubes or the difference of perfect squares, so you can't factor that at all. And then remember, you can't cancel any of this, right? You don't want to cancel the 3 and the 24 because, that 3y squared is married to 10x. The only way you can cancel them is if they're exactly the same factor. So you have to leave it as is, and that's adding the fractions together. Another mistake people make is they try to cancel here. If you cancel in this step, you're going back to the original problem. So you don't want to cancel once you have it over the LCD. In the final step, if you can factor and then cancel, you would, but if these terms are individual terms here, you can't cancel with the denominator. You need multiplication in order to cancel with the denominator in division. Let's take a look at a few more. If I said I had we'll say add these two. So if I said I had x over 2x squared plus 7x minus 4 plus, here we'll have 4 over x squared minus x minus 20. So you may want to pause the video and try it on your own. The first thing I would recommend is, making sure you factor the denominators completely. And if you were to factor here, the 2x squared plus 7x minus 4, there is no greatest common factor. You have three terms, you see a value in front of your x squared. That tells you either use an AC method or reverse FOIL. It's up to you what you prefer. If I was to use AC method, I would expect you to do it quickly at this point. Maybe I'll show you kind of a quick way of doing it. So AC would be, 2 times negative 4, so AC is negative 8, and I need things that will add to 7, right? So B is 7. So things that multiply to negative 8 and add to 7, well, that ends up being, a positive 8 and a negative 1. So I'm going to rewrite the 7x here as 2x squared plus 8x minus 1x minus 4. Okay, so I'm rewriting the middle term. This is using AC method, The numbers that multiply to negative 8 and add to 7 are a positive 8 and a negative 1. And then remember how it works. You have 4 terms, so that means you're factoring by grouping. For the first group, GCF here is 2x, so you'd factor out 2x, and you're left with x plus 4. For the second group, the GCF, make sure the first term is negative, you take out a negative, so it's negative 1 times x, and then negative 4 divided by negative 1 makes that a positive 4. And then what do these have in common? Well, they have x plus 4 in common, so you factor that to the front, times whatever's left over, so we have 2x minus 1. So I'm using that as my denominator here. The x squared minus x minus 20, you should be able to factor that fairly quickly. Keeping in mind, there's no GCF, you see 3 terms, you don't see a value in front of x squared. Don't go through and do a whole AC method. You can see that this is x times x right from the beginning. Multiplies negative 20 and adds a negative 1, because that's a negative 1 in the center. This would be a negative 5 and a positive 4, Negative 5 times 4 gives you negative 20. Negative 5 plus 4 gives you a negative 1. Once you factor these, now you're ready to find the LCD. And I went through the factoring pretty quickly because you should be able to do that at this point. If you didn't use AC method here, you would just do it by trial and error. So the LCD, remember how the LCD works. You want all the factors that appear in either fraction. So I got x plus 4 here. I have this factor of x plus 4 here. So I know I want x plus 4. Remember, you want the highest power of the factor you see. In this case, the highest power we see is just 1 for these. And the next factor I have is 2x minus 1. This doesn't have 2x minus 1, but if it shows up in either of them, you need it. So we need 2x minus 1. And then here I have a factor of x minus 5. I don't have any here, but you need an x minus 5. Remember, if it shows up in any of them, you need it. Once you have the LCD, now we're going to use that to rewrite our fractions. So, because when you add, most of the time, or actually all the time, once you get the LCD, you're going to put it all over the least common denominator. I'm going to put this whole thing over the LCD right now. So the LCD I've got is x plus 4 times 2x minus 1 times x minus 5. And I'm going to look at each term individually and what we would need to do to get to this least common denominator. So what do you multiply the x plus 4 times 2x minus 1 by to get to this LCD? Well, the answer is you multiply it by x minus 5. If you do it in the denominator, though, you have to do it to the numerator. So the numerator becomes x minus 5 times x, which I'll write as x times x minus 5. Because this is plus here, we'll keep this as plus in between. And then now I'm going to add 4. I know I'm going to have the 4 there as a coefficient. And then looking at the denominator here, we have x minus 5 times x plus 4. Well, what's missing to get to this LCD? Well, you need to multiply this by 2x minus 1. So I'd multiply by 2x minus 1 here. So I have to multiply the numerator, the 4 times 2x minus 1. So this is 4 times 2x minus 1. So all I did was, instead of writing it as two separate fractions right after I find the LCD, I'm going to write it as a single fraction and then show the operation in the numerator. It's the same thing, it's just saving you the step of having to write them individually. Now once you're here, make sure you distribute through, You have to distribute through this in the numerator. don't distribute through the denominator. You want to keep these as individual factors. It helps us simplify. So x times x becomes x squared. X times a negative 5 becomes a negative 5x. Here a positive 4. Make sure you take the sign with it. It's a positive 4. If this was a minus, it would be a negative 4 getting distributed. So positive 4 times 2x is positive 8x. Positive 4 times negative 1 is negative 4. And then this is all over that same LCD, which is x plus 4 times 2x minus 1 times x minus 5. Once you have this, we're going to simplify. This ends up being x squared plus 3x minus 4 over that same x plus 4 times 2x minus 1 times x minus 5. Now remember, don't just stop here. Alright, you don't want to stop at this point. You want to make sure that you factor the numerator completely, factor the denominator completely, and then see if anything cancels. Now, if nothing cancels, then it'd be okay to stop here. But if something does end up canceling, you want to make sure that you simplify completely. So the x squared plus 3x minus 4 in the numerator, 3 terms, no GCF, I don't see a value in front of the x squared. Right away, 2 sets of parentheses is x, and x multiplies a negative 4 and adds a 3. That'll be a positive 4 and a negative 1. So we have x plus 4 times x minus 1. This is over in the denominator, x plus 4 times 2x minus 1 times x minus 5. Once you have that, you want to cancel any common factors, both numerator and denominator. The x plus 4 cancels with the x plus 4. The x minus 1 can't cancel with the 2x minus 1. It has to look identical. Remember, they have to be exactly the same, so they're not the same factors. So I can write this as x minus 1 now. No parentheses needed in the numerator because 1 times anything is just itself. And in the denominator, 2x minus 1 times x minus 5. You don't have to distribute through. I actually leave it in factored form. Alright, let's take a look at just another one here. So for this example, we'll say subtract. Alright, so to subtract, I'll start with 8m over 3m squared minus 24m plus 48 minus 2 over m minus 4. Now you might want to pause this and try it on your own. To look at this here, first thing you want to do, remember, if you're adding or subtracting rational expressions, is factor the denominators completely and then find an LCD. So to factor this denominator completely here, first off, is there a GCF? In this case, there is a greatest common factor. It's 3, so you want to factor 3 out, right? Because 3, 24, and 48 all have a common factor, 3. I'm left with m squared minus 8m plus 16. And then you want to factor the inside of this. I have 3 terms. I don't see a value in front of the m squared, so 3 will stay 3 in front, and then I can make 2 sets of parentheses. M times m gives me the m squared, multiplies with positive 16 and adds to a negative 8. Well, we know they both have to be negative. And it's going to be negative 4 times negative 4, right? Because negative 4 times negative 4 gives you a positive 16. Negative 4 plus a negative 4 gives you a negative 8. And then remember, you want to write this. If you see a factor that repeats, you want to write it as that factor to the power. So that's 3 times m minus 4 squared. And this is going to be important. You want to write it like this. We'll talk about why in a minute. For the second fraction, m minus 4, is its own factor. It doesn't factor any further. There's nothing else you can do with it. So now we're ready to look for the LCD. The LCD here, remember, you want any factor that appears in either denominator, and you want to take the highest power of that factor. So here I have a factor of 3 here. I don't have any coefficient. Really, it's like a 1 in front of the whole thing. So the smallest value, 1 and 3, can both go into is 3. And then the next factor I have is m minus 4. Here I got m minus 4 squared. Here I have m minus 4. I want the factor with the highest power, so it's m minus 4 squared. And that's why it's important. If you didn't write that as squared there and you left these separately, you might write this as m minus 4 to the first power. But you need it as the second power because the highest power that you see in either fraction. So it's m minus 4 squared. Once you have that, you want to rewrite each fraction using the LCD. Now, in this case, the LCD, 3 times m minus 4 squared, is the entire denominator for this first fraction. So the first fraction doesn't really need to be rewritten at all. It already has the LCD. So we have 3 times m minus 4, the quantity squared. I'm going to do this all as one fraction, kind of like I did in the last example. I'll put both terms in the numerator because we're going through and we're rewriting each of them. So the 8m will stay 8m. I don't have to manipulate this at all. I don't have to multiply this by anything to get to this LCD. Really, it's like multiplying by 1, so 8m would just stay 8m. Minus, because this is minus. And now what do I multiply the m minus 4 here by to get to 3 times m minus 4 squared? Well, you multiply this by 3. You need the coefficient, so you're going to multiply this by 3. And then you also need another factor of m minus 4. So you're multiplying it by 3 times m minus 4. Whatever I do in the denominator, I have to do in the numerator. So I'm going to multiply this by 3 times m minus 4. So really I'm left with negative 2 and then times 3 times m minus 4. Notice how I wrote that. The 2 times the 3 you should do first and then distribute through into the m minus 4. It's usually easier to handle that way. So that's rewriting the second fraction over the common denominator, right? So it's a rewrite of the second fraction. Once you've done this, we're going to simplify in the numerator. So I get 8m minus, just do the 2 times 3 first, so it'll be minus 6 times m minus 4 over 3 times m minus 4 quantity squared. And then distribute now, make sure you take the negative with it. You're taking the negative 6. So 8m, negative 6 times the positive m is negative 6m. Negative 6 times negative 4 is positive 24 over 3 times m minus 4 squared. And then this will be equal to 2m plus 24, combining like terms, over 3 times m minus 4 squared. And now you should check to see if this simplifies. Now if it does, great. If it doesn't, then that's okay too. So this is equal to, we would factor a 2 out of the numerator, so I have 2 times m plus 12. Over here I have 3 times m minus 4 quantity squared. And you have to ask yourself, does any of this cancel? And the answer is no. 2 and 3 don't share any common factors that can cancel out. M plus 12 and m minus 4 are different factors, so you actually have to leave it like this. You know, if you didn't factor out the 2 there and you left it, that's okay, because it didn't simplify at all. But if it did simplify, you would need to have it there. So, you know, hopefully that example helps show you what happens if you have a factor that repeats, because sometimes people miss out on that part. We'll just look at one more together here. If I said to subtract, and I have 2a plus 5 over a plus 3 minus 3a plus 1 over a minus 4. So you may want to pause it and try it on your own. This one's a little more challenging in terms of what you have to do with multiplication, but it's the same process. So if I was looking at this, first thing I need is the least common denominator, right? Because I'm adding or subtracting fractions, in this case subtracting. Usually I'd factor the denominator as much as possible, but here they don't factor any further. So the LCD is, what you want here is the factors that appear in either denominator. So here I have a factor of a plus 3, so I need an a plus 3. Here I have an a minus 4, so I need a factor of a minus 4. And then once you have those, you again want to rewrite each fraction using the LCD. So I'm going to rewrite the whole thing over the LCD right away, because that's what's really going to happen when we subtract, right? They're going to all be written over the LCD. So I'm just kind of doing both fractions at the same time over the LCD. So for the 2a plus 5 over a plus 3, which factor is missing in the denominator to get to a plus 3 times a minus 4? Well, you'd have to multiply this by a minus 4. Whatever you do in the denominator, you should do in the numerator. So when I multiply the numerator by a minus 4, it's the entire 2a plus 5 times a minus 4. So So it's a minus 4 times the entire 2a plus 5. Make sure you put parentheses there. It matters. The operation subtraction, so we're going to have a minus sign there. And then the second fraction, to get a minus 4 to look like the least common denominator of a plus 3 times a minus 4, what do you have to multiply a minus 4 by? What's missing? Well, you multiply by a plus 3. If I do it in the denominator, I have to do it in the numerator. And if I do it in the numerator here, if there's more than one term, you need parentheses around it. So it's the entire 3a plus 1 times the a plus 3. So this is going to be minus. And then we have 3a plus 1 times the entire a plus 3. And now we want to distribute through. So the common mistake people make here sometimes they try to cancel along this, and you can't cancel these. Otherwise, you'd be working backwards. So we want to distribute through the numerator. Leave the denominator the same. So the denominator still will be a plus 3 times a minus 4. Distributing through here, we're going to FOIL. So a times 2a gives me 2a squared. A times 5 will give me a plus 5a. Negative 4 times 2a gives me negative 8a. And negative 4 times a positive 5 gives me a negative 20. Then we have the minus sign here. Keep the minus sign, right, because it's subtraction. Now when you FOIL this part, you have to put it all in parentheses because the minus sign is going to belong to all the terms that come after it. So FOILing here, I get 3a times a would give me 3a squared. 3a times a positive 3 will give me a plus 9a. 1 times 9 here, or sorry, it's an a. 1 times a here gives me plus 1a, and I'll just write it so you see the 1. You don't necessarily need the 1. 1 times 3 gives me plus 3. All right, and now we will combine like terms and simplify this. So I've got 2a squared plus 5a minus 8a is a negative 3a minus 20 minus, and then I'm going to do this kind of as two things at once. 3a squared, the plus 9a plus 1a is a plus 10a, right? So we have the subtraction of this whole thing means you distribute the negative to each term. So negative times a positive 3a squared makes us a negative 3a squared, because we're like a negative 1 times 3a squared. A negative times a positive 10a makes us a negative 10a. And you could have done that to each of these individually and then combine them. I'm just combining first and then distributing the negative. And then a negative times a positive makes us a negative 3. This is all over a plus 3 times a minus 4. And now we'll combine like terms. Combining like terms here. 2a squared minus 3a squared is a negative a squared. Negative 3a minus 10a is a negative 13a. Negative 20 minus 3 is a negative 23. This is all over a plus 3 times a minus 4. And then, you have to determine if this factors, you might be able to simplify. Taking a look at this though, you're not going to have an easy time factoring it, and I'll show you why. The most you might start with is, okay, I'm putting or here just to show you, it's equal. If I could factor a negative 1 as a GCF out of the numerator, if I do that I had negative 1, and then it would be a squared on the inside plus 13a plus 23 all over a plus 3 times a minus 4. And that's fine. If you want to factor this any further, though, you need numbers that multiply to 23 and add to 13. Well, the only factors of 23, since it's a prime number, are 1 and 23. They'll never add to 13. So factoring this doesn't really help you to factor the GCF out, but it might give you another equivalent form, because sometimes what you'll see is the negative 1 here will just be brought in front of the whole fraction, and you might see the answer written as a squared plus 13a plus 23. So negative, and then this fraction, a squared plus 13a plus 23 over a plus 3 times a minus 4. So all of these are correct answers. More typically you'll see this first one and the second one. If you factor out that negative 1, typically you'll see it written in the front like that in front of the whole fraction then. So hopefully these videos help give you some extra examples on how to add or subtract rational expressions, because I want to make sure you're prepared for all the different situations you might see.